If you look toward the constellation of Boötes, you are looking at a mistake in the architecture of the night. It is not just a gap. It is a refusal. Most of the sky is a crowded map of light, a dense cartography of stars and galaxies that follow a predictable, gravitational logic. But in this specific coordinate, centered near right ascension, 15 hours, and declination plus 35, the logic fails. There is a sphere of space so vast and so empty that by every known law of cosmic distribution, it should not exist. If the Milky Way were positioned at the center of this region, we would not have discovered other galaxies. Until the 1960s, we would have spent centuries believing we were the only thing in the entire universe. Scale of the Boötes void is difficult to hold in the mind without it slipping. It spans approximately 330 million light-years in diameter. To put that into perspective, the local group our immediate neighborhood containing the Milky Way, Andromeda, and dozens of smaller satellite galaxies is a mere 10 million light-years across. You could fit 2,000 Milky Ways, side by side, across the diameter of this hole. And yet, there is almost nothing there. It represents nearly 0.27% of the observable universe, carved out as a silent, hollowed-out monument to absence. When astronomers first began mapping the large-scale structure of the cosmos in the late 1970s, they expected to find a smooth universe. The prevailing theory was that, on a large enough scale, matter would be distributed evenly, like a fine mist. Robert Kirshner and his team at the Kitt Peak National Observatory weren't looking for a hole, they were looking for the mist. In 1981, as the data from their redshift surveys began to plot out on the monitors, the mist didn't appear. Instead, they saw a massive spherical exclusion zone, a place where the galaxies simply stopped. There is a specific kind of silence in the data from that region. Usually, a deep field survey is noisy. It's cluttered with the infrared signatures of star formation and the gravitational lensing of distant clusters. But when the sensors point toward the heart of Boötes, the noise drops away. The instruments return values that look like errors. They look like a sensor failure or a piece of equipment that has been capped. But the equipment is fine. The sensors are working. They are simply recording the physical manifestation of nothing. The standard model of the universe suggests that gravity should have pulled matter into these empty spaces over billions of years. Small fluctuations in the early universe should have grown into the filaments and walls we see elsewhere, the cosmic web. In this web, galaxies are like dewdrops on a spider's silk. But in Boötes, the silk is missing. The web has been torn. There is no clear mechanism in standard CDM, lambda, cold, dark matter, cosmology that accounts for a vacuum of this magnitude forming in the time. Since the Big Bang, a void this large should have taken longer. Then the age of the universe to clear itself of matter. We see a few galaxies there, eventually. After years of squinting into the dark with more sensitive arrays, we found them, isolated, lonely. About 60 galaxies inhabit a space that, by the average density of the rest of the universe, should contain at least 2,000. These 60 are not like the others. They sit in the center of the dark, far from the gravitational influence of neighbors, evolving in a strange, sterile solitude. They are the survivors of an erasure we don't yet understand. When you look at a photograph of a dense galaxy cluster, like Coma or Virgo, you see a frenzy of interaction. Galaxies colliding, gas being stripped, stars being born in the chaos of proximity. But when you look at the rare blurred images of the galaxies inside the Boötes void, you see a chilling stillness. They are often pristine spirals, their arms perfectly symmetrical because nothing has bumped into them for billions of years. They are ghost ships sailing across an ocean that has no end and no floor. The void does not just lack galaxies, it lacks the potential for them. The intergalactic medium there is depleted. The dark matter scaffolding that usually supports the birth of suns is either absent or so diffused that it cannot clump. It is a desert of such purity that it defies the natural tendency of the universe to create. In the professional literature, it is called a supervoid, but that is a clinical term for a terrifying reality. It is a place where the lights have gone out, and the reasons for it remain buried in the math. We are looking at a 330 million light-year radius where the universe decided to stop being the universe. Every time we point a telescope there, we are met with the same cold result. The signal doesn't bounce. It doesn't scatter. It just travels into the dark, forever, waiting to hit something that isn't there. Distance is a different concept inside the Boötes void. In our corner of the cosmos, the Milky Way is practically crowded. We have the Magellanic Clouds hovering like moths around a flame. We have the massive spiral of Andromeda pulling us toward a future collision. We exist within the Laniakea supercluster, a sprawling watershed of gravity where matter flows toward a common center. But for a galaxy trapped in the heart of the void, the horizon is empty. If you were born on a planet orbiting a star in one of the few galaxies located at the void center, your sky would be a terrifying blank. To the naked eye, the night would be an absolute, ink-black velvet. No distant nebulae, no neighboring star systems, no great attractor pulling on your home. You would be a singular point of light in a 300 million light-year desert. The psychological weight of that isolation, even translated through the cold lens of a telescope, is staggering. The galaxies we have found, they're roughly 60 out of an expected 2,000, behave like castaways. In 1987, astronomers identified a few of these outliers, like CG 547 and CG 693. They are weirdly productive. Because they don't have neighbors to strip their gas through ram pressure stripping, these galaxies are often rich in neutral hydrogen. They are star-forming factories, churning out blue giants in a frantic attempt to fill the silence. It is as if, in the absence of external interaction, the internal processes of the galaxy have accelerated, burning through their fuel in a vacuum. But there is a problem with the math of their location. When we measure the redshift of these galaxies, we find they aren't just sitting there. They are moving. However, they aren't moving toward anything. In a normal environment, a galaxy's velocity is dictated by the massive structures around it, the tug of dark matter, filaments, and the push of expanding space. In boats, there is no tug, there is only the push. The void acts as a source of repulsion, though not in the way we usually think of force, because the density of matter inside the void is so much lower than the density outside of it. The surrounding superclusters, the Hercules, the Corona Borealis, and the boat's clusters act like a gravitational vacuum cleaner. They pull everything toward the edges. This is the empty balloon effect. As the universe expands, the voids don't just sit there. They grow. They push back against the walls of matter, carving out more territory, thinning the few filaments that remain. This leads to a disturbing realization for those who map these structures. The boat's void is likely the result of a merger. Computer simulations suggest that small voids, bubbles of nothingness, can collide. When they do, they don't just blend. They pop the filaments of galaxies between them. Imagine two soap bubbles merging into one larger, more stable bubble. The thin film of water between them vanishes. In the cosmic scale, that film is composed of billions of suns, millions of planetary systems, and untold amounts of dark matter. If the boat's void is a merged supervoid, it means that at some point in the deep past, there were galaxies in that space. They were either pushed out to the crushing density of the walls, or they were simply dissolved by the sheer expansion of the vacuum. There is a specific galaxy, Iras 15.195 tambah 3.138, that sits in this region. It is a luminous infrared galaxy, glowing with the heat of intense star formation. It looks like it's screaming. In the middle of the great nothing, it is undergoing a burst of creation that shouldn't be possible without a merger or a gravitational encounter. But there is nothing nearby to encounter. It is an anomaly within an anomaly of fire, starting in a room with no oxygen. But we look at these 60 galaxies, and we see the remnants of a lost world. They are the survivors of a cosmic thinning. If the merger theory is correct, the boat's void is currently eating its surrounding. It is a structural instability in the universe that is getting larger. As dark energy accelerates the expansion of space, the empty places grow faster than the full ones. The voids are winning. The silence we detect when we point our radio telescopes at the center of boats isn't just the absence of stars. It's the absence of history. In the rest of the universe, the CMB cosmic microwave background radiation bears the imprint of early fluctuations, the seeds of everything we see. But in the direction of boats, the temperature fluctuations are unnervingly smooth. It's as if the record of the early universe has been wiped clean in this sector, leaving us with a blank page that we can't seem to write on. The data doesn't lie, but it doesn't comfort either. We are looking at a space that has been systematically cleared, whether by the slow, grinding physics of expansion or by a process we haven't yet named. The result is the same: a hole in the world, a place where the light goes to die, and where the few stars that remain are burning themselves out in a frantic, lonely race against the dark. The boat's void is not an infinite expanse. It is a room with walls. When we shift our gaze from the empty center toward the periphery, the data undergoes a violent transformation. We find ourselves staring at the great wall, a colossal filament of galaxies that serves as the boundary of the nothingness. This is the edge of the crater. Here, the density of matter spikes. Compressed by the expansion of the vacuum inside, thousands of galaxies are crushed together in a structural grid, held in place by the sheer pressure of the emptiness pushing out from the interior dot. To understand the structure of the void, one must understand the Zeldovich pancake. In the early universe, as matter began to collapse under gravity, it didn't collapse into spheres. It collapsed into sheets. These sheets formed the boundaries of the first voids. Over billions of years, the boat's void acted like a growing bubble in a loaf of baking bread, pushing the dough of galaxies into thinner and thinner layers. What we see at the edges are these flattened, eugenized flattened high-density regions where gravity is fighting a losing battle against the void's expansion. The transition from the void to the wall is not gradual. It is a sharp, jagged cliff in the distribution of matter. Using 3D mapping techniques, astronomers have traced the shores of this cosmic ocean. On one side, there is the absolute sterility of the 330 million light-year gap. On the other, the Coma supercluster and the Hercules supercluster rise like mountain ranges of light. The contrast is a physical shock to the system. It suggests that the void didn't just form, it carved itself. It is an active participant in the shaping of the universe, a predator of space that forces galaxies to cluster in fear at its borders. Within these walls, we see the true cost of the void's existence. Galaxies in the walls are distorted. They are subjected to tidal forces that rip gas from their disks, fueling massive black holes at their centers. This is the irony of the Boötes region. The center is a tomb of perfect stillness, while the edges are a chaotic furnace of gravitational violence. The matter that should have been distributed throughout the void has been shoveled into these walls, creating a crowding effect that accelerates the aging of the galaxies trapped there. There is a lingering question in the observational data regarding the internal filaments. In most large voids, we expect to find tendrils, thin, ghostly lines of dark matter, and sparse gas that connect one side of the void to the other, like the silk of a spider web stretching across a doorway. In Boötes, these tendrils are almost entirely missing. It is as if the vacuum is too clean. If they ever existed, they have been snapped. The absence of these internal structures suggests a terrifying efficiency. We are looking at a system that has reached a state of maximum entropy within its own borders. In the study of fluid dynamics, there is a phenomenon where a bubble becomes so large and stable that it resists any intrusion. The Boötes void has reached this maturity. It is a self-sustaining pocket of low-density space that no longer allows the cosmic web to repair itself. Astronomers often speak of the local void, a smaller, empty region near our own galaxy. But the Boötes void is a different species of anomaly. It is large enough to influence the CMB cosmic microwave background cold spots. When light from the Big Bang passes through a region as empty as Boötes, it loses energy, a process known as the integrated Sachs-Wolf effect. The void literally drains the energy from the light of the beginning of time. It leaves a bruise on the map of the early universe. When we measure this energy loss, the numbers don't always align with the observed number of galaxies. There is a missing mass problem, even within the nothingness. Some researchers have suggested that the void might contain vast amounts of warm dark matter that doesn't clump, or perhaps it is the site of a different kind of physics. Altogether, one where the expansion rate is slightly decoupled from the surrounding universe. The walls are the only thing keeping the universe looking familiar. If the Great Wall were to fail, if the gravitational tension holding the boundaries of Boötes were to snap, the void would spill out. It is a pressure vessel of nothingness. We stand on the outside, looking in at the crater, and realize that we are only safe because of the very gravity that the void seeks to dissolve. The structure is stable for now, but in the timeline of the cosmos, now is a flickering candle. The walls are thinning. The void is waiting. There is a point where physics becomes indistinguishable from a nightmare. If you were to travel at the speed of light, 300,000 kilometers every single second, it would still take you 330 million years to cross the Boötes void. To put that in human terms, if you had started your journey when the first amphibians were crawling out of the Earth's oceans, you would only be reaching the other side today. You would have spent the entire history of complex life on Earth, staring at nothing but the dark. This is the end state of the first signal. We are forced to reckon with the fact that the universe is not a cohesive whole, but a collection of islands separated by an expanding, hostile sea. The Boötes void is the largest of those seas. It is a reminder that the cosmic web is mostly holes. We focus on the stars because they are the only things we can see, but the stars are the exception. The void is the rule. The few galaxies we found in the center, those 60 lonely spirals, offer a glimpse into a potential future. In billions of years, as dark energy continues to accelerate the expansion of the universe, every galaxy will eventually find itself in a void of its own making. The big freeze or heat death of the universe is essentially the process of the entire cosmos becoming like Boötes. The walls will move further away. The neighbors will vanish over the horizon of the observable universe. Eventually, every observer will be a prisoner of a 300 million light-year silence. When Robert Kirshner first published his findings, the scientific community struggled with the implications. It wasn't just that there was a hole, it was that the hole was too clean, too spherical, and too large. It felt deliberate, not in a theological sense, but in a structural sense, as if the universe had a preferred direction for its emptiness. We look at the data and we see a shadow cast by something we cannot name. We see a place where the light has no purpose, because there is nothing for it to illuminate. As the sensors at the void signals continue to sweep the Boötes coordinates, the readings remain flat. There is no hidden population of dwarf galaxies. There is no dark matter bridge that we missed. There is only the realization that we are living on the edge of a great erasure. We are huddled together in the high-density filaments of the Laniakea supercluster, looking out across the shore at an ocean that does not want us. The first part of the signal ends here. At the lip of the crater, we have mapped the coordinates. We have felt the scale of the absence. We have seen the 60 survivors clinging to the center. But the true nature of the void, the reason it grew so large, and the secret of what is happening to the time and space within it remains unread. The signal is not over. It is merely descending into a deeper layer of the dark. If you look at Boötes tonight, you won't see the void. You will see the stars of the constellation, the bright orange glow of Arcturus, the familiar patterns of the northern sky. But behind them, 700 million light-years away, there is a sphere of nothingness that is slowly, patiently growing. It is a hole in the story of us, and the story is beginning to leak.